student, this mathematics lesson, grade 9, geometry and measurement. Here in this lesson, we'll try to see these terms or these pointers further on trigonometry, we'll see some like ideas about further on trigonometry and some problems which involve this trigonometry or using triangles, and another one we'll try to see some points about circles and some points on circles. So let's see the first part. Which is further on trigonometry. This like further on trigonometry. Here trigonometry deals about like angles and sides of a triangle. So when we discuss about angles, most of the time angles are measured using like radian and degree. So let's see what is angle. An angle is formed by two rays with common end point. We have these two rays with common end point. So an angle is formed by two rays with a common end point. So radian measure of angles. What is radian? Radian measure, one radian is the central angle, which is subtended by an arc of a circle which is equal to the radius. If you recall, the central angle is an angle which is formed by two radii of a circle. And this one radian, or simply we can say one rad, is the central angle which is subtended by an arc which is equal to the radius of a circle. This arc is equal to the length of the radius r. So one radian is the central angle subtended by an arc which is equal to the radius of the circle. So that one revolution in terms of radian measure is equal to the central angle which is subtended by 2 pi r. Here we need to find how to relate angle with radian measure. That's one revolution equal to 360 degree. That's one rad equals to 180 degree over pi, or if you recall, the approximate value of this pi is 3.14. So if you divide 180 degree with this one rad equals to this one, 57.3 degree. And one pi rad, meaning if we multiply the above one, if we multiply this one both sides by pi, we'll get the following result. That is 1 pi rad equals to 180 degree. Now we can like translate or convert radian measure to degree measure and degree measure to radian measure. One can convert radian measure into degree measure and degree measure to radian. To convert degree measure to radian measure, multiply with pi over 180 degree. Rad. And also to convert radian into degree measure, multiply with 180 degree over pi. So we can apply this like, we can convert this degree, convert 90 degree into radian. So that we can multiply this 90 degree with pi over 180 degree. So we will have this result. If we cancel this one, we'll get to that's pi over 2 rad, or it is 2 mean radian. And we can see also another one. Take this by yourself, convert this one into radian measure, and also we can convert radian measure into degree. Here we have 5 over 6 pi rad. So to convert this one, multiply with 5 over 6 pi, then times 180 degree over pi. So after simplification, we'll get the following one. We can cancel this. 180 degree divided by 6, which is 30 times 5, 150 degree, 150 degree. So you can also convert this one into degree using the same procedure, So that it is 5 over 6 pi rad times 180 degree over pi, which gives 150 degree. Another one, trigonometric ratio to solve right angle triangle. As we have stated before, a trigonometry states about sides and angles of a triangle. So let we have this right angle triangle, uses this right angle triangle. Side A is opposite to angle theta, and side B is adjacent to angle theta, and side C is hypotenuse to angle theta. So that here we have a trigonometric functions, that is sine, cosine, and tangent. A sine is defined in this way, that sine equals to opposite over hypotenuse. That sine theta equals to opposites of this angle theta is A over the hypotenuse is C, and cosine is defined as adjacent over hypotenuse. Then the adjacent one is B over the hypotenuse, which is C. And the tangent, which is like denoted by tan of theta, is opposite over adjacent, which is equal to A over B. So using these trigonometric ratios, we can solve different problems which is related to like triangles with side. And the trigonometric values of an acute angle is between 0 and 1. Let me show you like roughly. Here sine of theta is A over C. From the figure, we can easily compare the values of A and C. A is necessarily less than C, so that the ratio of A to C is necessarily less than 1. And it cannot be negative because both A and C like represents lengths, and also similar for the other values. But this value may be greater than 1, less than 1. It depends on the value of A and B. So the trigonometric values of acute angles basically for sine and cosine. For sine and cosine, its value is between 0 and 1. Its value is between 0 and 1. And every angles can be expressed in terms of acute angles. Every angles meaning there are angles greater than like 90 degree, they can be expressed in terms of acute angles. But here, we'll try to focus how to find the trigonometric values of obtuse angles in terms of an acute angle. If theta is an obtuse angle meaning an angle theta which is greater than 90 degree and which is less than 180 degree, or we can express 90 degree is less than theta, theta is less than 180 degree. So how we can find the trigonometric values of such obtuse angles? Sine of theta equals to sine of 180 degree then minus theta. And cos of theta equals to negative of cos of 180 degree minus theta, and tan of minus theta equals to 180 degree minus theta. Here, from this result, we can generalize the following one. Sine of theta equals to sine of 180 degree minus theta. Here, the value of theta is between 90 degree and 180 degree. So the difference of 180 degree with theta is exactly acute angle. It is acute angle. So the trigonometric values of an acute angle is positive. So that here you can generalize the trigonometric value of an obtuse angle for a sine function have a positive value. It has positive value. But for the remaining sine and the tangent, not cosine and tangent function, the trigonometric value of an obtuse angle is they have negative value. Negative values. They have negative values. From the above relation, cosine and tangent of an obtuse angle is negative. They have negative value. So let's apply this idea to find the value of this. If cos of 15 degree equals to x, what is cos of 165 degree in terms of x? Here, this angle is an obtuse angle, so we can express in terms of an acute one. Cos of 165 degree equals to, we can apply this, it's negative of cos of 180 degree, then minus 165 degree. So the difference of this equals to negative of cos 15 degree. But we know the value of this, cos 15 degree equals to x. That is negative of x. Negative of x. So you can practice this one. Cos 165 degree equals to negative of cos of 180 degree minus 165 degree, which is this value, So let's apply the idea of trigonometry to find some values. Find the missing sides of this triangle, meaning find the lengths of A and C. Here is given, it is right angle at this one, and this is 30 degree. So that to find this C, sine of 30 degree equals to, by definition, it is opposite over hypotenuse. So that sine of 30 degree equals to, its opposite is 10 over, the hypotenuse one is C, so that C equals to, or this sine of 30 degree is 1 over 2. So that C equals to 10 over 1 over 2, which equals to 20 centimeters. And also to find this A, we can use either tangent value or a cosine value. Cos of 30 degree equals to adjacent over the hypotenuse, but the hypotenuse one is 20 centimeter, which is calculated here. So A equals to cos 30 degree times C. That is cos of 30. It's like a value, the square root of 3 over 2 times 20 centimeter. So A equals to the square root of 10, the square root of 3 centimeter. Another example here, using the figure below, find these values CD, AD, AC, and AB. And it's given that triangle ABC is right angle at D. So that here we can apply the idea of trigonometry. Here, if we apply, and another given here, it's BC, which is 12 centimeter. Let's denote even with the variables x, y. So let's apply this. What is tan of 45 degree? From the definition, tan 45 degree is opposite over adjacent. That's y over x plus 12. And we have here, which is 60 degree. Similarly, tan of 60 degree then equals to, it's y over x. But the value of this tan of 45 degree is 1. 1 equals to y over x plus 12. That is x plus 12 then equals to y. And here, tan of 60 degree is the square root of 3. The square root of 3 then times x equals to y. So we have two equations with two variables. So we can solve x and y. In terms of y here, we can substitute 3, the square root of 3 times x. That's x plus 12, which equals to the square root of 3x. Now 12 then equals to the square root of 3x then minus x. If we factor out x, 12 then equals to x then the square root of 3 minus 1. So x equals to is 12 over the square root of 3 minus 1. Then to find y, we can substitute directly this value in place of x here, So these are the values that we have computed above. And you can repeat this procedure again. So using the above two equations, the value of x and y is solved in this form. X is 12 over the square root of 3 minus 1 centimeter. And let's see about circles also, circles. Under this lesson, let's see what is symmetrical property of a circle, symmetrical property. If you recall, a symmetrical property of generally figures, if a figure can be folded or divided into halves so that two halves match exactly, then such figures are called symmetrical figures. For example, let's take this a square paper. Let's take this is a square figure. If we fold along this line, one half of the figure is exactly congruent to the other side and the other figure, and if we fold along this figure, one half coincides over the other side, or one half coincides with the other half. In such cases, these figures are called symmetrical figures. And generally, if you recall, regular polygon is also symmetrical figure, and a line of symmetry is equal to the number of sides. For example, if we have regular hexagon, since it is regular, it will have 6 line of symmetry. Every regular polygons are symmetrical figures, and a line of symmetry equals to the number of sides. Symmetrical figure is the figure that has at least one line of symmetry. Thus, circle has infinitely many lines of symmetry. Let's look here. This one is the center. This one is the diameter. If we fold this part along every diameter, one half coincides with the other half. So we can draw infinitely many diagonals on the circle, and every half coincides with the other half, so that we can generalize circle has infinitely many line of symmetry. So that generally a circle is a symmetrical figure. It is a symmetrical figure. From the above figure, this one is already the point that we have discussed, and here also the diameter is sometimes called the largest chord in the circle. The diameter is sometimes called the largest chord in the circle, and chord is a line segment whose end points is on the circle. Let's take, for example, this line segment. The two end points are on the circle, so that this line segment is called a chord. And the largest chord of a circle is called a diameter. Another point, if two chords in a given circle are equal, here, let's take this one, EF. Let's denote this one, the center, with O. So this radius is a perpendicular bisector of chord EF, perpendicular bisector. Here, if we draw from F to O, it is the radius R, and from E to O, which is radius R, and this line segment is a common side for both triangles. Let's say this one is X is common side. So these two triangles are congruent. Even you can recall the idea of similarity. They are congruent by RHS, right angle hypotenuse side. So if they are congruent, the corresponding angles are also congruent. This is 90 degree, this one is 90 degree. And this side is congruent to this one. So that the radius is a perpendicular bisector of any chord. Perpendicular bisector of any chord. Here, let's apply this idea to solve this problem. In the figure below, the radius is 5 centimeter. The distance from A to O, AO, let it is 5 centimeter. And the length of the chord is 8 centimeter. That chord is CD. CD is equal to 8 centimeter. AB is the diameter. AB is the diameter. Then what is the distance of A from the chord? Distance of A from the chord meaning length of AF. Length of AF equals to what? So from the above idea, this diameter is a perpendicular bisector of the chord. Since the chord is 8 centimeter, each will have 4 centimeter. Each will have 4 centimeter. Each will have 4 centimeter. So that here we can observe this is right angle triangle. Right angle triangle OFD. OFD is right angle triangle. If it is right angle triangle, we can find the distance from the center to this point, the center to this point, by applying Pythagoras Theorem. Let this will be x. Let this will be x. This is given, which is 5 centimeter because the radius. And this is half of the chord, that is 4 centimeter. Okay, so using right angle triangle here, x squared then plus 4 centimeter square equals to 25 centimeter square. 25 centimeter square. That's x squared equals to 25 centimeter square then minus 16 centimeter square. That's x squared equals to 9 centimeter square. That's x equals to 3 centimeter. 3 centimeter. We are asked to find this distance of A from the chord meaning perpendicular distance. From A to O, it's given, which is the radius, 5 centimeter. And from the center to this one is 3 centimeter. 3 centimeter. So distance of A from the chord is the sum of 5 and 3. That is 8 centimeter. That is AF equals to AO, then plus OF. That's equal to 5 centimeter, then plus 3 centimeter, which equals to 8 centimeter. So distance of A from the chord is 8 centimeter. These are the competitions. These are the competitions. You can repeat this problem by yourself. And also here we have another problem. In the figure below, AB, chord AB is 12 centimeter. Chord AB is 12 centimeter. And CD is 15 centimeter. Which one is nearest to the center? Let this will be the center of the circle. Center of the circle. If AB is 12 centimeter and CD is 15 centimeter, which one is nearest to the center? From the above definitions, we have seen the largest chord of a circle is a diameter. And the larger one is always closer to the center. So that from these two numerical values, AB is 12 centimeter and CD is 15 centimeter, which is given. So a numerical value of CD is greater than AB. So that this chord CD, will more closer to the center than AB. So that CD is closer to the center than chord AB. Another one, if two tangents are drawn from a point 2 if two tangents are drawn outside to a circle, if two tangents are drawn outside a circle, then they are equidistant. If two tangents are drawn outside the circle, then they are equidistant, and a line segment joining the point and the center bisects the angle. Here even we can prove that PA is congruent to PB. PA is congruent to PB. Here always the tangent is perpendicular to the radius. The tangent is perpendicular to the radius. And also this is a common side. It's common side. Common side. And also for both triangles, this side is the hypotenuse one. It's the hypotenuse. The hypotenuse one. And these two sides are congruent because they are radii of a circle. They are radii of a circle. So these two triangles, that is triangle P, A, this is the center, let's say O, is congruent to triangle P, B, O by RHS. Right angle, the hypotenuse is congruent, and one side. So if they are congruent, the corresponding sides are also congruent. That is PB is congruent to PA, sides in corresponding position. And also if they are congruent, the corresponding angles are also congruent. Angle APO, angle APO is congruent to angle APO is congruent to angle BPO. These angles are congruent, meaning a line segment drawn from this point to the center is a bisector of this angle, a bisector of this angle. So that generally here we have tried to cover the following ideas about like trigonometry. Under trigonometry, the trigonometric values of an obtuse angle can be expressed in terms of an acute angle. It can be expressed in terms of an acute angle, and the cosine and tangent value of the cosine and tangent value of an obtuse angle is negative. The cosine value of cosine and tangent function is negative. They have negative values. They have negative values. But sine have a positive value. Sine have a positive value. And also, an angles can be converted from radian to degree and radian to degree measure vice versa. And also in the circle, we have covered this one, a symmetrical property. Symmetrical property. A given figure is said to be symmetrical if it has at least one line of symmetry. If it has at least one line of symmetry, it must have at least one line of symmetry. One line of symmetry. But since a circle has so many or infinitely many diagonals, if we fold along every diagonals, one half coincides with the other half. So circle has infinitely many a line of symmetry, infinitely many a line of symmetry. This is all about our lesson, though you can also like see different examples on your textbook and different references. See you next time. Thank you.